This video is on sketching quadratics. So what do we mean by a sketch? So we've plotted before, but what do we mean by, what's the difference between a sketch and a plot? Well, hopefully you recognise that this graph here is not a quadratic, it's a cubic, but the idea of sketching is the same. So when we plot something, we are plotting exact coordinates that we figured out and we are connecting them with a smooth line. When we're sketching, we're just interested in kind of the general shape of it and some specific key points, so the important points of the graph. We don't need to have a scale on our axis. You can see here the only numbers we've got are where it's crossing the axis, and that's what's important in this graph. And it's just got a general shape. We don't know specifically where this graph is in this section, but we know it's in this part of this quadrant of the graph, and that's what's important. So when we go to sketch a quadratic, we have 4 key points that we're looking for, 3 that we're really kind of wanting to put on every single time, and a 4th one only if required, if we've been asked to. So the first one, that's probably the most important, is the general shape. Is it a smiley face, or is it a hill or a frowny face? And we're going to take that from, well, is it a positive x squared? So remember, a smiley is where it's something like y equals x squared. And then a frown or a hill is where it's y equals minus x squared. So in this case, this graph would be a positive x squared graph because it looks like a smiley face. Next thing we're concerned about is the roots. So that's what we've been doing recently, solving an equation, and that is what we mean by that makes the output 0. This is also called the solutions. So when we found the 2 solutions, let's say x equals to minus 3 and x equals to 1, well, this would be minus 3 and this would be 1. And then the third one that is important is the y-intercept. So with a straight line, hopefully we remember that it's in the form y equals mx plus c, where this was the gradient and this was the y-intercept. That's where it crosses the y-axis. Well, with a quadratic, it's in the form y equals to something x squared, so ax squared plus bx plus c, and it still is that this plus c on the end is our y-intercept. So looking at this graph, it could be like a minus 1 at the end there, because it's just a bit lower than the 0 point. And then a turning point. So that is where the graph stops going downhill and starts going uphill. So we can see at this point it kind of turns around and starts going up. We're not going to focus on that today. If you want to stick around right till the end of the videos, I'll show you one method that you can use to find that. But it's not something we are generally required to do at GCSE too much. It's more of an A-level sort of thing, the turning point. So, example 1. I think I've got about 5 examples showing different types of things. I've got 2 questions for you to have a go at, and then I'm going to do one extension question at the end showing you about the turning point, just in case you're interested and you want to kind of get everything at one stage. So, first we need to kind of go through these steps. I'd probably do it in reverse order because it's easier to start at 3. Well, is it a smiley face or a frowny face? Well, it's a positive x squared. So therefore, it's a smiley shape, or it looks like a U. So that's point 1, 3 done. So it's going to look something like that. Well, what is the y-intercept? Well, the y-intercept is just this number at the end. So the y-intercept is going to be minus 2. So we can even tick that on our graph. It's going to cross here at minus 2. And then for our roots, well, we need to factorize, then solve, which is what we've just been practicing. So if I go to factorize this, into two brackets, I'm going to have x minus 2, x plus 1. To solve this, I need to set y equal to 0, so 0 equals to x minus 2, x plus 1. And then when I solve this, it's going to be what the opposite that this sign is. So x equals to 2 instead of minus 2, and x equals to minus 1. The reasoning behind that is because we need to ask when each bracket equals to 0. So the solutions are when x minus 2 equals 0 and when x plus 1 equals to 0. And when we solve this, we add 2 to both sides. So x equals 2. See, we've got the same thing there. And I'm going to take 1 from both sides. So x equals minus 1. So these are our roots. I'm going to cross them off, try and get it roughly to scale, but it's not so important. 2 and minus 1. I then just need to kind of do a U shape through these. So starting somewhere up here, it doesn't have to be perfect, just make sure you get your 3 points in there. And if you're a bit off, you can always just kind of rub it out and redraw your cross so it looks nice. The main thing they're wanting in this is these 3 key points, and for your quadratic to just look relatively normal and not be something, I don't know, that isn't just a U shape. So example 2. Is it a smiley or is it a hill? Well, it's a positive x squared again, so we know it's going to be a U shape. What is the y-intercept? Well, it's just this number at the end, so minus 6. So I can mark that on here already as a place I know it's going to cross. The roots, well, I need to factorize. Factorizing this is going to be x minus 3, x minus... Nope, that is not correct. Let me get my rubber. I'm jumping ahead there, I did that too fast. That is going to be x plus 6, x minus 1, because 6 take away 1 gives me 5, and 6 times minus 1 gives me minus 6. So I need to then solve this, so set it equal to 0. You might be able to just tell what the solutions are from this, but it's really important to show this line of working. So then my solutions or my roots are x equals minus 6 and x equals 1. I can mark that on, so minus 6 and 1. Let's do my best to draw a nice U from this. Sometimes I find it helpful to turn my page sideways. There we go, that's looking good enough. Okay, so that would be that one drawn. Example 3, so another similar one. Well, it's going to be a U shape again. I've got a other way example in a bit. And my y-intercept is 9. Hopefully this is coming nice and easy to you now. And my roots, well, I need to factorize. This is going to be x minus 3, x minus 3. So we might see something a little bit different here. We need to solve it. So 0 equals to x minus 3, x minus 3. So my roots are x equals 3, x equals 3. Well, that's actually, we can just write that as x equals 3, can't we? Because we don't need to write it twice. And that is going to be here. When we have something like this where we've got, this is called repeated roots, you have the same number twice, it's just going to touch the axis. So I'm going to come down here, cross through my 9, and it's just going to touch here and move up again. And that's because we don't want it to cross the x-axis twice. Our solutions are always on the x-axis. And we only want it to touch it once at 3, so it's going to just touch. So it just touches the x-axis. So that's a key thing to remember. Okay, an example like this. Well, is it a smiley or a frowny face? It's a smiley face again. What is my y-intercept? Well, I don't really have any numbers at the end, but it's kind of like a plus 0, isn't it? So my y-intercept is 0. It's going to cross through here. And then my roots, well, I need to factorise it. This one I can only pull out, it doesn't have to be double brackets, I can only pull out a factor of x. So I'll pull out x from that, makes it x, and an x from this makes it minus 4. When I've got something like this, when I go to solve it, this is kind of like having x minus 0, isn't it? Or x plus 0. So my solutions, or my roots, would be, well, x plus 0, x equals 0, sorry, and x equals 4. So when you've just got an x on its own like that, the solution is going to be 0, because if we turn that to a 0, 0 times by anything in this bracket will be 0. And we can see, well, our roots is where it crosses the x-axis, and we've already know there's a point at 0, so that seems to link up with the y-intercept being 0. And then we've got 4 there, so this is going to come down through here and up like this. So, a different example, you can see this has got a negative x squared here. So this is actually going to be a frowny face or a hill. The y-intercept, still we find it the same way. It is minus 4, so I'm going to write that there. And before we factorise this, we've got to do one special thing. We want to first factorise out the negative. So when I do that, I'm going to put the negative at the front, and I'm going to change all the signs of this because I'm kind of timesing everything by minus 1, because I'm factorising out minus 1. So this will be, instead of minus x squared, it'll be positive x squared. Instead of positive 5x, it's going to be minus 5x. And instead of minus 4, it's going to be 4. Then I just want to factorise what is in this bracket. We can keep that minus at the front there. It's not going to do anything to our solutions. Our solutions will be found the exact same way. You could even ignore that minus sign now, for now. So if I go to factorise this, well, I'm going to have minus 4 and minus 1. So then my solutions, or roots, call them anything, is going to be x equals to 4 and x equals to 1. So x equals to 1, x equals to 4. I need to go ahead and plot this. Remember, it's a frowny face graph, so we need to start from down low and draw, that's probably my worst one yet, isn't it? And draw a hill, make sure it's nice, and one continuous line. You get drop marks if you do this sort of stuff. That's a big no-no. You drop marks for that. They'd rather it be less accurate and just one line. Okay, 2 for you to have a go at. So to just pause the video and have a go, I would recommend following the order I've been doing, so working from the bottom of this up and filling in the table as you go, and then once you've got your 3 pieces of information, have a go at plotting it. And I'm going to reveal the answers in 3, 2, 1. Okay, so this first one, we've got a U-shape with a y-intercept will be plus 2, because it's just the 2 on the end here. And the roots, well, when we factorise it, we could get x plus 1, x plus 2. So our roots will be minus 1 and minus 2, and it's going to look something like this. Harder one here. Well done if you got this one, or if you're confident you've got it so far, it's going to be an N shape. Even getting that far, you pick up a mark for just drawing an N shape, and you pick up a mark for getting your y-intercept, so it's two easy things there. Even if you get stuck at the next bit, 'cause I agree it's quite difficult, getting them two is good. And then hopefully when you factorised it, you get -2 and 4 as your solutions, because first we'd have had to, well, make it look like this, and then when you go to factorise that, I'll do it down here, you'll have got your two brackets with x plus 2, x minus 4, and that's where you'll have got your two solutions from, setting that equal to 0, and then plotting it like this. Remember it to go that shape. So, just a quick little add-on here. We can be given a graph, and we could be asked to find an equation. So we've gone from equation to graph, we could have to be asked to go from graph to equation back. So, thinking backwards, well, if I had a root here of -2, what would my bracket have looked like? Well, my bracket will have looked like x plus 2, because when I find the solution to that, it would give me -2. And similarly for this, when I was asked, if I've got a solution of 1, my bracket would before say x equals 1. So my equation is going to look like this. And I know I'm not putting a negative sign anywhere at the front here because it is a smiley face graph. I know it's going to be a positive x squared. And then to get it into this form, that's basically just saying expand the brackets. So when I expand the brackets, I'm going to get x squared plus 2x minus x minus 2. Let's simplify that down. Here we go. I got x squared plus x minus 2. And then again on this one, well, if I've got a solution of -1, my bracket must say x plus 1. And if I've got a solution of positive 3, my bracket must say x minus 3. I'm leaving a bit of a space at the front, and hopefully you can tell why. It's a n-shaped graph, so this is a negative x squared equation, so I need to put a minus sign at the front there. I'm just going to expand my brackets normally, but leave them in a big bracket. So this will be x squared plus x minus 3x minus 3. Let's collect that up. And then my final step, hopefully I can squeeze it in here, I just need to change the sign of everything because I've got a minus sign outside. So it's going to turn to minus x squared plus 2x plus 3. And that's going to be my final equation there, squidged in on the bottom. So if we go through some features of a quadratic, this is from a GCSE paper, and they're just some quick one markers that hopefully we should be able to get. So looking at this quadratic, we've not been given the equation, we've just been given a turning point, or we can also call it a minimum point. For the sketch shown, circle the correct answer in the following. The value of a is, well, a is what our x squared is. What does that part tell us? Well, that tells us if it's either that shape or that shape. It's a U-shaped graph, so we know it's going to be positive. And negative. If it's neither of them, then it would be 0 if it's just a straight line. So this would be positive because that gives us a U-shape. The value of c. Is the value of c 0, positive or negative? Well, the value of c tells us what our y-intercept is, and that is low down below the x-axis, so that would be negative. The solutions to this equation are both 0, both positive, both negative, or one of each. Well, our solutions are here and here. Remember, solutions and roots are interchangeable, they mean the same thing. When I write that SOL and then with an N on top, that means solutions. Well, we've got one in the negative and one in the positive, so it's one of each. I should really be circling this, shouldn't I? So what did we say for this? Positive, negative, it's one of each. And then the number of solutions to the graph we've got equals minus 6 is. Remember when we had something, we said it was equal to a number. We'd want to draw the line y equals minus 6 and then see where they meet. Well, if I drew the line y equals minus 6, this is minus 3, it's going to be somewhere down here. And they never cross, so it would be 0. Okay, so that's all I've got for you. If you want to stick around and see the turning point stuff, feel free. So this is a bit of an extension. I'm just going to do one example of it. We want to plot our graph first, or at least find the solutions. So, to find the solutions we need to factorize. I've taken one from before. This is going to be x plus 6, x minus 1. So my solutions, or my roots, are going to be x equals minus 6 and x equals to 1. So when I draw this graph, I'm not going to bother about the y-intercept because I don't need it for this. It's going to look something like this. A quadratic, quadratics are always symmetrical. So the turning point is halfway between the roots. So this will be exactly halfway, in this case, between minus 6 and 1. Well, what is bang in the middle of minus 6 and 1? We can add them together and divide by 2 if we want to do that. And that gets me minus 2.5. We can check, well, to get from 6 to 2.5 is 3.5 going this way, and that's 3.5 going that way. So we know the coordinate, the x coordinate of this, is going to be minus 2.5. We then need to sub x equals to minus 2.5 into our quadratic to find the y coordinate. So really careful with brackets when you're substituting this in. So I've put brackets around minus 2.5 and then a squared outside the brackets, plus 5 lots of minus 2.5 minus 6. And it's given me a fraction. It's given me minus 49 over 4, or we can write that as minus 12.25. So that is my turning point. So that's one way of finding the turning point. It's a bit difficult to understand. The maths isn't too hard, I don't think. Just remember it's halfway between the roots, so find what's banging halfway, then substitute that x value into your original equation to find the y value that links to that point. Okay, that's everything from me today.